Okay, so today's class we're starting the Pythagoras chapter in our module. So today we're going to look at labeling triangles, so vertices, sides, then we're going to start labeling right triangles. After that we're going to look at area of squares using the Pythagorean theorem. And lastly today we'll look at the Pythagorean triplets or triads. So firstly is labeling vertices and sides of a triangle. So each vertex of a triangle is labeled with a different capital letter, and then the sides that are opposite, so here we have a vertex with capital B, and then the side opposite is labeled with the same letter but in the lowercase. Okay, so capital B for the vertex and then lowercase b for that side. All right, same thing here. Here we have a capital N showing the vertex, and right opposite that is its corresponding side here, so lowercase n. Here is a completed triangle, capital A, vertex. There's the side, lowercase a. Here's the vertex, capital T. There is the side in lowercase t, capital M, and lowercase m. All right, so that is how a vertex and a side is labeled for any triangle. All right, so looking at this triangle here as an example, we just have to label the sides of this triangle. Okay, so let's label the sides of this triangle. So here we have the capital M, so therefore right directly opposite would be its side here. This would be labeled the lowercase m. Here we have the capital O for the vertex, so right across from that we would label this with a lowercase o. And then here we have the capital N for the vertex, so directly opposite. This is the side N. Okay, so next we're labeling the vertices. So we have our sides A, B, and C. All right, so if this is side A, this would be the vertex, capital A. This is the side B, so therefore that vertex would be labeled B. And here we have side C, so this vertex would be labeled with a capital C. All right, next we're going to look at specifically right triangles because this will lead us into the Pythagorean theorem. The Pythagorean theorem works for right triangles. All right, so all right triangles are labeled the same way. The side that is opposite the right angle, so here is the right angle, the side opposite that is always called the hypotenuse. So in all of these examples, it's labeled as C, and this is the hypotenuse. That is what that side is called. All right, and it's always, well, in these examples, it's labeled as C, which makes sense when we get to our formula. The other two sides are labeled A and B, A for altitude, and then B for the base. All right, so here we go again in this example. There's our right angle. Directly opposite the right angle is our hypotenuse. And the other thing to keep in mind is the hypotenuse is the longest side of the triangle. All right, so here again is the right angle. Directly opposite is the hypotenuse. So you do need to be able to find the hypotenuse, okay, when we're going to be solving for these triangles. All right, so the Pythagorean theorem is for right angled triangles, and it's in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So a squared plus b squared is equal to c squared. C is the hypotenuse, and it's always the longest side. So again, find your right angle, and right opposite that is your hypotenuse. So in this diagram, we're looking at c squared, which has a side length of 5. So 5 squared, which would become 25. Our a is a side length of 3. 3 squared gives us 9. And then side b, which has a side length of 4. 4 squared is 16. Now on both sides, we end up with 25. So 25 is equal to 25 units. Therefore, this is a right-angled triangle. All right, let's look at this chart here. This is in the 7.3 module where we are filling in this chart. So the first one is done for us. So the first one is correlating to this triangle here. All right, so that's how this chart works. So number 1 is number 1 here. So we look at our area of the square drawn on one side. So 15 meters here. 15 squared is 225. Next, 1 second. Okay, so 15 squared becomes 225. Then we're going to take our next side, which is 36. So 36 squared is 1,296. So just double check that in your calculators. And then we're going to take the sum of the area of the squares of the first two sides. So 225 plus 1296. Okay, and you should get 1521. Okay, everybody's tried that in their calculators? Okay, now take the area of the longest side, which is 39. You can't bother me again, okay? Go.
Okay, sorry.
Go. Close my door. Close it, close it. All right, so now if you take 39 squared, you should also get 1521. Okay, so remember 39 squared is 39 times 39. So did everybody get 1,521? Yeah, that's what you should be getting. So therefore, is it a right triangle? Therefore, yes, it is a right triangle. Okay, so I'm just going to show that again, and I'm just going to show it here on the side with the formula. Okay, give me 1 second to just record that as well. Oh, it is recording. Okay, so just to double check that with the Pythagorean theorem, so we did 15 squared plus 36 squared has to equal to 39 squared. All right, 15 squared was 225. 36 squared was 1,296. 39 squared was 1,521. Then when we added these two together, we also got 1,521. So both sides are equal. Therefore, yes, it was, or this triangle is a right angle triangle. All right, I'm going to give you guys a couple minutes to try number 2. So number 2 here, you got the two sides, 8 and 9, and then the longer side, which will be the hypotenuse, which is 12 meters. So give that a try. If that is a right triangle or not, answer in the private chat, please. Okay, so for question number 2, area of one of the sides, so we'll use 8. 8 squared, 8 times 8, that's 64. Then we have the other side, which is 9. 9 squared, 9 times 9, that is 81. Okay, and then we'll take the sum, so add 64 plus 81, and that gives me 145. Next, we'll take the area of the square drawn on the longest side, so that would be 12. 12 squared is 144. All right, these two are not equal, so therefore this is not a right triangle. All right, and just showing that in the formula, A squared plus B squared equals C squared. So 8 squared plus 9 squared has to equal to 12 squared for it to be a right triangle. So 64 plus 81 has to equal to 144. 64 plus 81 is 145, and it does not equal. So therefore, it is not a right triangle. Okay, so next, we're just looking at Pythagorean triplets or triads. So these are the certain sets of numbers that are called Pythagorean triplets or Pythagorean triads because they can be used to make up the sides of a right angled triangle. So for example, when we were looking at the video, 3, 4, and 5 is a set of numbers that is a triplet or a triad because when we use the theorem, the Pythagorean theorem, they satisfy the formula a squared plus b squared equal to c squared. All right, and always use the largest number, so in this case 5, as the hypotenuse when you're putting it into the formula. So the example here are the triplets 5, 12, and 13, a Pythagorean triplet. So in this case, the number 13 is the largest, so therefore we would use 13 for the hypotenuse. So, a squared plus b squared is equal to c squared. The other two they can be interchanged. So we'll just go 5 squared plus 12 squared has to equal to 13 squared for these numbers to be a Pythagorean triplet. So here we get 25, 12 squared is 144, and then 13 squared is equal to 169. Add these two together, 25 plus 144, it does equal to 169. All right, so that does work out. Therefore, they do form a triplet. All right, so therefore we can say the numbers 5, 12, and 13, they are a Pythagorean triplet, and therefore a triangle with these sides would be a right-angled triangle. All right, let's try this one as well. The numbers 6, 8, and 10, are they a Pythagorean triad? So same thing, we're going to use 10, it's the largest, we'll use that as our hypotenuse. So here is our formula. So 6 squared plus 8 squared has to equal to 10 squared. And here we get 36, and here we get 64, and it has to equal to 100. 36 plus 64, it does equal to 100. So therefore, yes, these numbers are a Pythagorean triad, 6 and 8 and 10. All right, I'll give you guys this one to try. Here. All right, so are the numbers 5, 6, and 7 a Pythagorean triad or triplet? So we would use 7 as our hypotenuse. The other two we're going to use as the legs. So a squared plus b squared is equal to c squared. So 5 squared plus 6 squared has to equal to 7 squared. So 25 plus 36, does it equal to 49? And 25 plus 36 is 61. That does not equal to 49. Okay, so these numbers therefore are not a Pythagorean triad or a triplet. So therefore, a triangle with these three sides, it would not be a right angled triangle. All right, so we'll stop there today.